Good evening, everyone. Today on the bench we got a package that came in. Just received it a few moments ago. So we're going to open it up. And I think I know what this is. And it should be a customer's item in for repair. Have a note. Yep, this is what I thought it was. Have the microphone. A lot of static today. The weather is completely crazy. Last week it was freezing, and today it's 70 degrees. Alright. Okay, enclosed is in the YSK 857 box is a Kenwood TM-721 2 m 220 mobile. Has a receive issue on the 220 side. And goes and talks about please go ahead and fix it and let me know this and that, you know. And thanks very much for repair on this, and I like your videos. Alright, this is from Bill. I did a repair on one of these in one of my prior videos. I'll link that one down below. Another very nice looking Kenwood TM-721. This is the FM transceiver, covers the 2 m and 220 megahertz bands. And the problem with these radios is there's another radio, I can't remember the model number, that is just like this, but it's 2 m 440. And there's a service manual for the 2 m 440 version. The problem is there's no service information for the 2 m 220. So when you got to work on the 220 board, you have no schematics to go by, and you have no service information. You cannot use the 440 schematic because it's a complete different layout. So when you're working on these, you'll just have to work it on through you know, trial and error. There's a few things we can use in the other service manual to find out what it is, but I'm going to hook it up and we'll verify what Bill is saying and see what we can do with it. Okay, I got the radio on the 2 m side connected to the dummy load and have power, and we have the service monitor set to 144 megahertz. So we'll turn the unit on. Have audio. The squelch is working, and we'll key the radio up. And yes, we have power out on 2 m side. Okay, we'll switch over to 220 and check that. Alright, we're now on the 220 side, so what we'll do is check transmit on 220. And we have plenty of power out. That looks good. Test the deviation. Radio test 1, 2. Radio check 1, 2. 1, 2. About 5 kilohertz. So that looks good. So let's go to back to 2 meters and check the receiver. Okay, the radio's back on 2 meters. So make sure we'll turn down. IFR is hooked up. We'll go to generate. And we got received down to about minus 118 dBm. So that looks good. Now we're on the 220 side. And we'll turn the generator on. And the radio starts receiving on 220 somewhere around about minus 178 dBm. And we get full quiet in about minus 50 dBm. Okay. So we know that we have verified that the 220 megahertz receive is not receiving correctly. So we're going to take the case off and then we're going to look at it. And you know, through experience I already know what's wrong with it. But let's say I don't have the experience. How do we determine what is wrong with this radio? We know that there's a problem with the 220 receiver, but we have no documentation. We have no schematics. We have nothing to go on. So we'll see, can we get down into that and figure this out. So I have the top and bottom cover off the radio, and we're looking at it, and we're lost. We don't know which way to start. You know, which side is which is the 2 meter, which is the 220. Well, you got kind of a bit of a giveaway. If you look at your antenna connectors, one side is listed 144, while the other side has 220. And what this helps you in is that the 144 megahertz goes onto the top side. This is your PA area. So this is your power amplifier for your 2 meter side. There's your coax coming in. So we'll turn it over, and you'll see this coax goes down into this circuit. And it comes in here. You can see the coax comes in through here. Now, your power amplifier is over here on this side. So here is where you should find your coax jumper that comes from the exciter side and into the power amplifier. Now you can pull the data chip on this M5774 chip, and you can get the pinouts for it, and you can find which is the input. So if we follow that piece of coax See, it goes right here, so we know the input's over here on one of these two pins. So we know that this is not receive cable. So we'll look here, and you'll see the coils, and it comes in to this side and goes straight into this connector here. That is RA1. See if you can get that in there. So RA1 is our receiver input into the boards. So here you can see our bandpass filters and our first stages. So, you know, how can we check the RF amplifier? Where is the RF amplifier? Well, if you look over top of the radio, we know that since these are the first stages, the RF amplifier has to be close somewhere here. So if you look in this stage, you see no transistors on top. So we know that the RF amp has to be underneath. So I removed all the screws and disconnected all the cables to this board. And what we'll do, we're going to pull this board out, and we're going to start here at this connector, and we're going to trace back. Okay, so let's see if we can basically make a block diagram of the circuit of this radio. This way it might give you a little bit better understanding how things are laid out in it. Okay. Start off with the antenna. We'll come in. This would be the antenna switch. We'll go into our first RF amp. This will be our first mixer. Some crystal filter. This will be your main mixer, your IF stage, and your detector. AF amp, speaker, it's 455 kilohertz. And let's see where we at here. This will be a PLL. So come back and feed into the mixer. This will be our TX amp and buffer stage. To our PA, we can get our amplifier. And from there we go back into the switch. So this is basically just a rough block diagram of how the radio should work, and you would also pick up your microphone input through your mic circuit here. So, and the VHF is going to be completely identical to it, just flipped around, and it'll share the AF and mic amp circuit. So it's very easy to figure out. It's not really complicated at all. Okay, so let's see if we can get a little bit better understanding here on the RF amp. start off here. It's R1. Usually you'll find a capacitor that's going to ground. Then we'll have another feed capacitor. Okay. And resistor going to ground. Usually that'll be a output of the FET, and this will go through an adjustable coil. Should have a resistor going to ground. Capacitor. So that's basically the first circuit. So we see right here on one will have our input and 3 will be our grounds. That's how we can follow our single through. But that's just a rough sketch of it, not to scale. And all this is basically going to be about the same in just about all these lines of Kenwood radios. So you could probably take the Kenwood TM-721 400 megahertz schematic and pretty much follow through this the same way. It's not going to be very much difference. It's just in our radio, our front end is going to have coils, where the 440 is going to have helical resonators. Okay, we're looking at the bottom of the board, and this is our input connector for the antenna. You see the 2 grounds on it. The connector will have 2 grounds, and then your center conductor will be on this end. So you got a ground here, then your center conductor. So we'll follow this out. We'll find the 2 grounds and our center conductor. We come through here through this chip capacitor, and we'll follow right on down. Get the light on this thing a little bit, and you'll see there's a bypass cap here going to ground. And then there's another capacitor that it goes through into this trace. When we follow this trace, we find this 4-pin transistor here. And this will be your first RF amp. So, at this point, we know that since this is a 4-pin device, this is going to be an FET, and that's your RF amplifier. So you can take the time and take your voltmeter, put it on continuity test, go to the input, and check the other pins. And you can see, and I hope you can hear the meter beep. I'll do it one more time just in case you didn't. We're on the input of this transistor. And we're showing short on 3 pins. So we can pretty much rule that that transistor is no more good. So it looks like the radio has took an overload and has took the transistor out. This is very common on these 220 boards. I don't know why, but it seems like real strong stations can wipe out this transistor very quickly. Static electricity I've seen one, a guy have drove under a drive-through port and his antenna raked across the metal roofing and took out his 220 receiver. So what we need to do is remove this transistor and put a new one in. So as you can see, I've got the connectors over to this side, so I got the board oriented under the microscope. And I got the microscope real close so that you can see the orientation. Since this transistor has 4 pins, you got to really make sure you put it in the right way. You don't want to put it in upside down, or you're going to have all kinds of problems. So you can see the transistor has 3RS written on it. So we're going to remove this transistor and install the new one. But we'll use hot air, but you got to be very careful when doing this, because you got all these other components around here, so you don't want to blow them off the board. This is a good time if you got some metal tape or some capstan tape that you can put on the board around the RF amp, and this way you don't blow those components off the board. So here you can see I have covered the board in capstan tape, and this will hold all the components in place while we heat this up and remove the old transistor. Alright, we have a hot air gun heating up, and we'll see can we get this thing off. And there we have it. Get all sorting good and heating it up. I didn't think about cutting that on. Get all that old solder off of it. I don't know. I know back then they didn't use lead-free solder, but I still like to put fresh solder on it and work around all 4 leads, and that'll pull all that old contaminated solder off. Okay, you grab a new transistor. Okay, a new transistor. A little flux on the board. This is where I would really love to have a trinocular microscope, but we don't have that, so we got to do it under this USB microscope. And when you're drawing like this, you're looking up and you're not looking directly at your work, so it's a little confusing doing it this way. I don't reckon y'all want to see a coin, do you? There we go. And we have our new RF amp installed. Okay, I'm sorry, I had to get under the cam and look at that real good to make sure all the points look good. And I see nothing wrong with that. Alright, let's get it reinstalled and see what it does. Okay, the board's reinstalled. Just turned the power on. And I got the generator set at minus 78 dBm. That's where this radio started receiving before when we did our test on 220. So we'll switch over to generate. And if you can see, even now we have a full scale on an S meter. We have minus 78 dBm. We'll turn it down. And she's receiving it about minus 118. Okay. So, just a quick little repair. As you see, no schematics. So we were able to pull the board. Well, we determined which board it was, the problem was in. I was able to pull the board, followed the path to the first RF amp, and changed it out. And that solved the problem. So, sometimes you have to bite the bullet and do it the old-fashioned way and just, sort of reverse engineer what you have, because you can't always find documentation on these receivers. Now, if you would have went on Google and searched Kenwood TM-621A, no 220 receive, you would have found some information online. And that information is stuff that I posted, and also on my other YouTube video of repair of one of these. So, there is some documentation out there, but we don't always have access to it. So, 15 minutes and this radio is back, ready to go back to the customer. Anyway, I hope you enjoyed this quick little repair. If you did, give it a thumbs up. And if you haven't, please subscribe. And we'll catch you in the next video. Thanks.